All right. All right, guys. So let's look at the first example. Um, yeah. Wouldn't I mean it's not much work to it. Um, okay, guys. So let me show you as far as domain and range. Um, Now, guys, I'm gonna give you a little bit of vocabulary here. This is what they call your A value, sometimes known as a multiplier. All right. Yeah, very similar. Only thing different, this is to the 1/2 power, or it would be to the 1/2 power, and the quadratic is squared. Okay. Now, guys, I call this your horizontal shift. Now, guys, I'm not saying this is math, the actual math definition of it, but this is what I'll refer to it for. Refer to it as. All right, now this is also. I put equation, but it's actually an inequality. Let me put inequality for domain. Inequality. So when you go to get your domain, you're looking. When you get your domain, guys, you're looking at what's underneath the radical here. Okay. I call this your D value. That's your D value. This is your vertical shift. So guys, underneath the radical is your horizontal shift. Okay. The D value, which is outside, okay, that is your vertical shift. All right. Okay. Now let's talk about domain for a minute. Okay. Domain. So if it says, so if it asks you what is the domain of this function, okay, um, guys, I can pretty much guarantee you will see something like this on NCFE. They really do like to ask you questions like this. Okay, it's really really simple to solve. Okay, what you're going to do now, guys, we have dealt with imaginary solutions or complex solutions where the square root is a negative number. But in the case of radical functions, when you graph these things, this cannot be less than zero. Okay, so remember, this cannot be less than zero. It cannot be a negative number. So how to find the domain is you take your underneath your radical. Hello, I will. Yes, ma'am. All right, now what you're going to do, guys, you're going to take what's underneath the radical, and remember, it's got to be greater than zero. Okay, it can be zero, but it's got to be greater than equal to zero. Okay. So remember, the domain's got to be greater than or equal to zero. Okay. So you're going to set this right here. Okay. Now, so we're going to subtract four. guys, mark that. I'm going to write that in a minute. This is your domain here. Okay. And guys, if you think about it, this number is always going to be the number. If you plug it in here, is going to be equal to 0. Make this equal to 0. Because if I plug in -4 here, what's -4 plus 4? 0, right? That number is always going to be that number. Whatever that number is, it's always going to be the negative of that number. Okay? So that's your domain. All right, now. All right, what is the range of this function? If it asks you that, algebraically, what you're going to do, I'm going to bring my original square root function down. Now, guys, what you're going to do is you're going to get the range, you're going to plug in the lower limit of your domain. Okay, your lower limit is this guy right here. That's the smallest that number can be, and it be greater than or equal to 0. Because guys, what happens if I plug in a -5 here? What's -5 plus 4? It's -1, right? Can this square root be a negative number? Can't be a negative number. So this is the lower limit of your domain. So what you're going to do, you're going to plug that number in. So it's easier to get the domain first. 3. Okay, so I plugged in the lower limit. Now, guys, what's this going to always be here? -4 plus 4 is what? 0. It's always going to be 0. So it's 3 times the square root of 0 minus 2. Okay? Now, so 3 times the square root of 0 is 0. Okay? That's your range. Right. Yep. Mhm. Yeah, let's see. Okay, so now, the main you set this greater than or equal to 0. To get your range, you plug in this number that you found from your domain. You plug it in for x, and you get your um, range. Okay. Now, guys, make sure you put this down. Now, guys, remember. Let me show you. Let me show you what the general form of this is. All right. This is your general form. That's the general form of a square root function. A times x minus h plus k. Okay. That should look pretty familiar. That almost looks like vertex form of a quadratic. What Mr. Robinson was saying earlier. Okay. Now, guys, as far as this sign right here, if your a value, now guys, your a value is your multiplier out here. Okay. Your a value is your multiplier. Okay. That's going to be if A is greater than 1. Okay. If A is greater than 1, then it's going to be Y value is greater than or equal to. That's going to be the sign right here. If A is less than, make that 0, I'm sorry, greater than 0. If A is less than 0, it's going to be Y values less than or equal to. Okay. So guys, if A is greater than 0, greater than or equal to 0, it's going to be Y values greater than or equal to this number. Okay. If A values are less than 0, if the A value is less than 0, okay. So guys, if I knowing this right here, okay. All right. So if A value is greater than 0, it's Y value is greater than your K value, which is this number right here. Okay. If your A value is less than 0, it's Y value is less than the K value. Okay. So now let's um let's go ahead and graph this, and then we'll get our transformations and stuff like that. All right. Now, guys, what you're going to do, you're going to put this in Y equals. So 3 times the square root of x plus 4. All right, so you're going to put it in your calculator just like you see it. Okay. 3 times the square root of x plus 4 minus 2. Make sure, guys, that minus 2, make sure that minus 2, notice it's not underneath the radical. Make sure you keep it that way. If you put that minus 2 underneath the radical, it'll mess it up. Okay. Notice that the radical stops at x plus 4. Okay. All right, now then we're going to go to our table. Now remember, guys, the lower limit of our domain was -4. Does everybody remember this? Our domain, x values greater than -4 was our domain. Notice, guys, what happens when you go beyond, if you go less than -4, what do you get on the y value? You get error. That's another good way of telling you what your domain is. If I'm looking at this and I say, well, when I go to -4, I get a number. But when I go to -5, I get an error message. What that means is this is the lower limit of your domain, -4. Okay. So that being said, if you had that right there, you say, well, I know my domain is x values greater than or equal to -4. You didn't have to really set it equal to greater than or equal to 0. That's how you do it algebraically, but as far as the calculator goes, I know that -4 is my lower limit because when I go to -5, I get an error message. Okay. All right. Now, how can I find my range here, guys? Just looking at, if you scroll down, notice where the lower limit. Remember, guys, to get our range, we plug in our lower limit of our domain, which was -4. Everybody remember that? The number that's with the lower limit of your range of your domain, the y value with it is your range. Okay, and guys, depending on if it opens up or down. Now, easiest way to remember this, I wrote it just a minute ago. The easiest way to remember this, if that number is positive, the A value, it opens up. Okay, it goes up. If it is negative, opens down. Okay. All right, now. So what you would do, guys, you'd go to your graph, and you would start. I call it my origination point: -4, -2. I call that my origination point. That's where it originates from. Guys, remember I can find that. I can do it by the algebra we did on the notebook paper, or I can find it with my calculator. It's either one you want to do. When you pull your calculator up, remember if I go to the lower limit, it's the error message. That is your origination point. Yep. When it gives you an error, you know that the coordinate, the next coordinate is your origination point. So what you do, the graph it be -3, 1, -3, 1, which is there. Now, guys, sometimes you'll get ugly decimals, but a lot of times what I do is I try to graph whole numbers. That's 0, 4. See if there's any more whole numbers. 5, 7. And guys, that should be enough to make a square root curve. That's what a square root curve would look like, or your function. No, parabola. These are actually exact opposites of each other. This is a square root, where a parabola is no, it's a square root. Only way I know you could do that if you put a negative here. It'd be a sideways parabola. You think so? I ain't gonna go in. I don't want to go in. All right. So guys, let's talk about our transformations now. Okay. Guys, transformations are pretty easy. Guys, what does H stand for when you're talking about transformations? Horizontal, right? Left to right. Now, guys, remember when we find our when we do our transformations, we start at the origin. Okay. Let me take this calculator. All right, we're gonna start at the origin. Now, and what we're gonna do, we're gonna say what it took to go to our from the origin to the origination point. Okay. Now, horizontally, what did I do? I went 1, 2, 3, 4 left. Right. So horizontally, I went 4 left. Transformations are really easy because you just once you get your origination point, just go from 0 to 0, and that's your transformation. Okay. All right. Now horizontally. Now what does V stand for, guys? Vertical. Okay. Now my vertical is -2, right? So I'm gonna go 2, 2 down. And guys, we do have an A value transformation here. Guys, just like a quadratic, if this number is greater than 1, then it stretches. Now, guys, 3 is greater than 1. Okay, So it stretches. And guys, what it means by stretch as far as a square root function, it means it gets steeper. It gets more steep. Okay. Notice it'll if the bigger that number gets, the steeper that curve will get. Okay. Guys, let's look at number 9 because this is going to be a good one to go with. Um, Guys, another thing too, I was thinking about because we're doing sine and cosine functions in Math 3. This this number right here, the number outside, that is I'm thinking about I was thinking about kind of sine and cosine functions. That is known as your k value, not your d value. That's known as your k value. So if you want to go back, that's the very first thing we wrote down. That is your k value. That's the number on the outside of the radical. All right. Now, guys, what value is this? Is that the a value or the k value? That's the k, right? The a value is always multiplying your square root. Guys, 1/2 times the square root of x minus 3. This is your a value here. Okay? This is the a value. This is actually your k value. So I can actually write this way. Y equals negative 1/2 square root of x minus 3 minus 5. That would be, now we got our a value and our k value. Yeah, because this right here, you can tell this is the k value because it's not multiplying the square root. You know this is the k value, even though it's written up front. Usually it can be written in the back like this or written in the front like this. And you know it's not because it's got a sign, it's got a minus sign in that 1/2 between it and the radical. So you know that's not the a value. This is k. Now, looking at your notes you took, how do I get the domain of this function? All right, you're on the right track, Bridget. So what do I set greater than or equal to 0? Yeah, whatever's in the radical, right? Good. So my domain is what's underneath the radical, set greater than or equal to 0. Okay. The reason why, because this has to be greater than 0, or not, if not, it's going to give me an error message. Remember the error message we got on our last one? All right. What do you think my range is going to be? Well, let me finish it up. I'm gonna add 3. That'd be x greater than or equal to 3. That's my domain. X value is greater than or equal to 3. Why did my group move back here? Colin them. But why don't y'all move back here? Okay. All right. Now Guys, this is what I would do. Okay. Now remember my range. Let's go back to our calculator just a minute. Let's go ahead and plug this into my calculator. You can plug it in just like you see it. The calculator knows which is which. All right, now that's -5 minus 1/2. All right, so I got it there just like I see it. Okay. All right, I graph it. All right, let's go to our table. Second graph brings us to our table. Now, guys, what is my range going to be? Now, think about this. We know it's going to be y values because range deals with y values. Now, however, is my range going to be y values greater than -5 or y values less than -5? Well, look at it. If I go greater than -5, what happens? I get an error, right? If I go greater than -5, right here, I get an error. So is it going to be greater than or less than? It's going to be less than. Y values less than equal to -5. Okay? Now, guys, the point here, 3 -5, what did I call it on my last graph? Starts with an O. Origination point, right? So 3 -5 is my origination point. So 3 -5. Now, since I have my origination point, can I do my transformations now? Yeah, I'm gonna go from the origin. All right, now I had to go 1, 2, 3 right. So horizontally, I went 3 right, 3 right. What's my vertical transformation? 5 down, right? 5 down. This is one of these things you don't have to think too deep into it. Just spit it out pretty much. Okay. Now there's my A value. Okay. Now if A is negative, make sure you write this down somewhere. If A is negative, it opens down. Okay. If A is negative, it opens down. That is a transformation. Now, guys, notice this is a fraction, right? This is a fraction. Okay. Now, on your paper somewhere, write this down. Guys, what's these little bars mean? Absolute value. So that means if a negative is a positive, it's positive is positive, right? So if the absolute value of A, which A is -1/2, okay, A is -1/2. If A is between 0 and 1, which 1/2 is, okay, that means it compresses. So it can either stretch or compress, okay? If it is a fraction between 0 and 1, it compresses. So the A value here compresses by 1/2. So there's your transformations. Okay. Domain, range, and transformations. Okay. Now, let's go ahead and graph this. Well, I know my origination point is 3, -5. Okay. Now, another whole number is 7, -6. So 7, -6. Guys, I'm going to be honest with you. That's probably all you're going to get out of it. That's your answer. All right, guys, I'm going to let you can go ahead and get started. Do number 6. See if you can do number 6 and give all the transformations and stuff. Domain. Give the domain, range, and transformations, and see how you can do. We'll come back here in a minute together and we'll compare answers. All right. It is.
If you know how to read a graph, yep.
Back together and compare answers. All right. Now the domain, the domain of number 6, you should have x values greater than equal to 4. That should be your domain. All right, that should be your domain. All right, your range should be y values greater than equal to 1. All right, now your origination point here, guys, will be 4, 1. Okay. All right. Now, your transformations horizontally, you went 4, 4 right. Because remember, guys, you're going from the origin, and from the origin you went 4 right, and then vertically you went 1 up. And then you do have an A value transformation here. That means it stretches by 3. All right. Then as far as graphing goes, somebody, yeah. All right, guys. Y'all, you can go ahead and finish the rest. Guys, if I see your phone out, guys, I'm gonna take it. I've been seeing phones. I haven't said anything but if I see you with your phone out, I'm gonna take it. All right. So you need to keep it up.